So once again, no, we go back to our discussion on vectors, and this is the exercise that we had. No, we performed this last meeting. Part of our activity, hopefully, no, we'll be able to cover a seat work towards the end of this lecture, and as well as the performance task. No, I'm going to allow you to see it. No? Now, resultant vectors again, no, is the one that we call as the final drawing, no, or the final line that we draw. No, if we draw two series of vectors, no, like displacement 1 and displacement 2, no, when we draw them one after the other, the third side, no, that closes the two other vectors is known as the resultant vector. No? We can probably think of a resultant vector as the effect, no? The overall effect of the two vectors together. No? Other ways of doing that is what we call vector addition, no? When we add vectors together. So two or more vectors can be represented by a single vector called a resultant. This vector may be found, no, by using the graphical method. So we draw using ruler, protractor. We can use it. You can use our Pythagorean theorem if they are directed, no, north and east, no, in a right angle, no, formation. We can use our tangent function there, no. So Pythagorean theorem and this method, no, is considered mathematical. No? So a graphical method is an approximation or the closest estimate, no, that we can have for our answer, because it will largely depend on our scale, no? And how we use our protractor will also determine, no, how good we are, no, in finding the angle. No? But if we will use the Pythagorean theorem and the trigonometric functions like tangent, no, then that will be the closest or the accurate answer. No? We call that as analytical or mathematical method because we use our calculator there and some formulas. No? Now, an extension of our mathematical method is known as the component method. No? But we will have to understand first, no, that vectors will have what we call components. No? And maybe, no, along the way we will mention what we mean by the component method. No? So how to draw a vector? So if we are applying our graphical method again, no? How do we draw? We draw it, no, one vector after the other. And we usually term it as tip to tail. Huh? So that's how we draw our vector. No? So if you employ graphical method, others would call it as tip to tail. If we think of it as a polygon, no? If we think of our ended figure as a polygon, sometimes we also call it as a polygon method. No? So our figure will either end up like a triangle, no? A figure that will close into a triangle after drawing the resultant, or it will look like a trapezoid, no? A four-sided figure. So sometimes, no, they call it also as polygon method. Now, when you are dealing with three or more vectors, no? But if there are only two vectors to resolve or to find a resultant, then we end up with a triangle. No? So more often we apply the ruler there, no, and apply the protractor. No? So a ship sailing 25 kilometers north, no? So we can plot this. We use a scale. No? So if our scale is 1 centimeter of our length is 10 kilometers, then we will draw it, no, having 2.5 centimeter length. No? So again, if you recall our way of graphing that. No? So the graph will have 2.5 centimeter equivalent to 25 kilometers already. No? So we could not draw the 25 kilometers in a piece of paper. No? So we have to use a good scale where we can illustrate, no, carefully, no, the drawing there. No? If the values there are in thousands of kilometers, we cannot also draw thousands of kilometers. So we will have to change our scaling, no, to be able to fit the drawing there, no, in our single piece of paper. No? So that's the need of the scaling. No? So the scaling changes depending on the need, no, for you to adjust the value there. So in this case, we use 1 centimeter for every 10 kilometers of distance, and then we draw the corresponding figure. No? Okay, no, let me erase this one. So maybe this is how we draw our 25, no, our 25 kilometers. So we have the starting point below, and then we draw 2 segments, and then a half centimeter of drawing. No? So that's 2.5 centimeters already. No? So this length is already 25 kilometers if we use our conversion value. No? So that's how long we do it. If there's a succeeding vector, then we draw it at the tip, no, of the last vector. So if this is displacement 1 and we will draw displacement number 2, then we will connect displacement 2 at the tip of this drawing. No? So punta lang siya. No? Now this is what we need, no, ruler, protractor, no, in our work. No? So graphical method, no? Josh was observing, no, an ant that crawled, no, along the tabletop, no, sa babaw sang lamisa ko, no, may nakita siya nga subay nagalakat, no. Now with a piece of chalk, he followed the path, no. He determined the ant's displacement by using the ruler and protractor, no. So here are the displacements, no, of the ant, no. So how many displacements are considered? So this is the first one. No? We can call this as D1, displacement 1. Here is our D2. And this is the direction of D2. And then we have D3. No? So all in all, there are 3 displacements. And therefore, we have to close the path of the ant, no? After we draw it tip to tail, by drawing the 4th side. No? And we call that 4th side again as the resultant vector. No? So we'll start with the D1. No? So we will have to have a reference point. No? And para nga ma-drawing ta siya. No? So this is how we draw probably our east. No? So maybe we can draw somewhere here our legend, no? our starting point. No? Sorry. No? So this is our starting point, guys. So maybe this is our starting point, and somewhere here, now we draw our first vector D1. No? So we have there, how many segments supposedly? We will have 2. No? So 2 centimeters will be equals to the length walked by the ant. No? Now, after that, we will draw at the tip of this next, of this previous D1 value ng vector, no? RD sub 2. No? So we will go north of east, no? So north of east, ang aton kadtuan, no? So ang iya nga number of degrees is 32 degrees, no? So notice this, no? Our D2 is not only north of east, but there's an angle 32 degrees north of our east, no? And how will that look like? No? So this angle, no? So we will have to measure the angle here. So this is north of our east, no? So if you think of it, if this horizontal line going right is east, this direction going up is north, no? So we will have to measure our 32 degrees from this location, no? So this is our 32, no, degrees, no? That's north of our east. Okay, then what will we do next? We will draw our third force, no, or third vector, I mean. No? Third vector is another angle, no? So may another angle naman siya, which is 22 degrees west of north. No? So when we draw our third vector, so we will draw 2.3 centimeter. No? Now our D sub 2, guys, must be 3.5. No? So use your ruler, measure 3.5. And then you stop the drawing. No? Now the third one, no? So our third figure, guys, ako natin D2, no? 32 degrees na siya. And our D3 must be, no? west of north. So if this is our north na line, no, ang dash line, we will go west, no, of that north. No? And how many degrees? 22. No? So we'll measure 22 degrees west of that given north na line. No? So this is now our three vectors. How long is D3? It's 2.3 centimeter. No? Amo naton nga kalabaon siniyo. Use your ruler, measure D3, no, equal to 2.3 centimeter. So where is the resultant now? No? Where is the displacement of the ant? Diin na karon ng ant, no? Based on, no, our starting point. And I'm going to mark our starting point again. Our starting point is over here. No? In this dot. No? Dili siya nagsugod. So how far is the ant from this point? No? So most likely, ang aton nga ant, no, will have to walk, no, this length. Amo ni nga aton nga length nga iya nga lakto. No? Amo ni actually ang length, no, or I mean, ang displacement iya nga final. No? Okay, now, how long is that? So you get your ruler. No? You are going to get your ruler. No? So this is the third side. We call it as the displacement, no, resultant displacement dr. No? Now, how long is that? Then you get your ruler and you will measure the angle. No? Now, this time when we measure the angle, no, our measurement of angle must always be based, no, diri sa aton nga horizontal line. No? So, ang aton horizontal line, you have to measure it, no? 46 degrees. No? Kung gamiton mo na guro imo protractor da, no? So you will get 46 degrees and the value, no, of 46 degrees is north of east. No? So parehas mo sa 32 kay na. No? This is north of east. No? So we will measure it, no, based on this horizontal line. No? Dira ta masugod measure sa aton angle. No? Now in trigo, I think we call it as a reference angle. Reference angle is measured, no, from the x-axis or the horizontal axis. No? Now how long is dr? Our d sub r is around 5.8, no, centimeter, and maybe now you will use your protractor in getting the value. Now, so this is one method, no, graphical method. No? Okay, do you have a question for this? Sinong may question how we got the answer? No? Okay, so continuing, no, so continuing, we go to another approach. No? So steps in the graphical method. No? So we use a scale, a coordinate system, meaning x and y axis. You draw the first vector from the origin. Draw the second vector, no, at the head of the first vector. No? So sa punta yan, no? Ibutang mo na da ang tail sang second vector. No? And then continue, no, if there's a third one. No? Now, once you are done, no, then draw the last side, closing the figure, no, from the starting point to the tip of the last vector, and that is now called as your resultant. So the resultant, guys, no, is again, no, dependent ang iya value. The value of the resultant depends largely, no, on how accurate is your scale and how much you read the number of degrees in your drawing. No? Now, using Pythagorean theorem, the result of two vectors, no, that forms right angle, you can use your Pythagorean theorem. So if this is the shape of our two vectors, then you can just simply use the Pythagorean theorem. No? So if one is going east and then the other one is going north, no, then dr is simply equal to, no, the Pythagorean theorem na square root of d1 square, no, plus d2 square, and then you extract the square root. No? Then the angle is opposite over adjacent, and you get the arctangent, no, of the angle. No? So the angle is measured again from the x or the horizontal axis. No? Okay, now a plane flying due north 100 meters per second, no, is blown by a strong wind, no, 500 meters due east. No? So the plane is flying north, while, no, there's a wind that blows, no, in another direction 500 meters per second. Mas kusog, no? Maybe no, since 500 siya, then we draw it no longer, 5 times as long as your 100 newtons. No? So this is east. No? So the 100 Newton goes north. So where is the resultant here? No? So our resultant will close this side. No? And again, no? If we will use our Pythagorean theorem there, no? Then maybe no, our angle again will be measured from the x-axis. No? Dili kita ma-measure sa x-axis. No? And that angle anyway no, will be similar to the one above. No? So according to your geometry, no? So ang duha na ka-angle similar, wala na sila, no? So you may as well get the angle above, no, sa diri nga end. So but how long is the resultant first, no? So that's 100 square. So ang aton nga Pythagorean theorem, 100 square plus 500 square, no? I-add na sila kag square root, so you will end up with 509, no? Now, inang 509 is not graphical approach, no? But that is using your formula, no? So this is an accurate answer, no? Now, if we will use our tangent function, no? So that's opposite nga 100 over 500, no? Because if you look at this angle over here, no? So dili kita maglantaw sa sinang angle, no? Which is also equal to the one below, no? So that will be 100, no? Over 500, no? Sa aton nga activity. So 100 over 500 is 0.2, no? So arc tangent of 0.2 gives you 11.31 degrees, no? And we measure it, no? North of our east, no? So based on the line nga horizontal, no? So that's the value, no, of our Pythagorean theorem, no. So the angle there was 11.31 degrees, no. So previously, no. So given the situation there, no, so we end up with our no answer here, no. So when we substitute that, no, and end up with this angle north of our east, no. Now, at this point, we will have our seat work, no, and you are going to go, no, to your pairs, no, and try to answer this, no.